In section 4.6, problem 31, you are solving a nonlinear inequality, and this one is a little bit more complicated than problem 30 that we did because of the fact that we have some work to do before we can even factor. So, first step in this problem is to get one side to be equal to 0. Well, that's pretty easy. We just subtract 1/2 from both sides of this inequality. But now, what I need to do is combine all of this into one big fraction. So I need a common denominator for all of these fractions. Well, the common denominator between these three fractions is 8a. So my common denominator is 8a. So then in this first fraction, I changed my denominator by multiplying by 2, so then I should multiply my numerator by 2 as well. Second fraction, I did not change the denominator, so I should not change the numerator. And in the last fraction, I multiplied my denominator by 4a, so I should multiply my numerator by 4a as well. Then I can combine all of these fractions into one single fraction where the denominator would be 8a, and I have 7 minus 4a in the numerator. Now in this particular case, different from section 4.6 problem 30, I really don't have any factoring that needs to be done at this point. I can just jump right to figuring out what my critical points are. In this case, what makes the numerator equal to 0 is the number 7 over 4. If a were equal to 7 over 4, that would make the numerator 0. And the denominator would be 0 if a was equal to 0. So those are my critical points in this particular problem. Then I need to test each region, just like I did in problem 30. So choose any number that you want to the left of 0. For example, you could use -1. Well, -4 times -1 is positive 4. 7 plus 4 is a positive number. Remember, we don't really care what the value is. We just need to see if it's positive or negative. And then -1 times 8 is clearly a negative number. So a positive divided by a negative is negative, but what we want are numbers that are greater than 0. So we should not shade this region. Then we want to pick a number from this region to test. I would choose the number 1. When I plug in +1, I've got 7 minus 4, which is positive, so that didn't change. And then in the denominator, I've got 8 times 1, which is also positive. Positive divided by a positive is positive, and that is what I want, since I'm looking for things that are greater than 0. So I'll shade that region. That will contain solutions. Then I need to choose a number larger than 7/4, and again, you can choose ridiculously large numbers if you want. For example, 1,000,000. 7 minus 4 million is very clearly a negative number. 8 times 1,000,000 is positive. So I've got a negative divided by a positive, which is negative. That's not what I want, so I do not shade that final region. Now all that remains is to indicate which endpoints we get to include in our solution. Well, since 7/4 makes the numerator 0, and not the denominator, we can include that as part of our solution. So we use a square bracket or a solid dot. But since 0 makes the denominator 0, we cannot include that as part of our solution. And then if you're writing out your solution in interval notation, you would simply write it as the interval from 0 to 7/4, where 0 is not included, but 7/4 is included.